All right, let's dive in. Today we're tackling prime numbers,
Prime numbers.
those mysterious numbers that are greater than 1 and only divisible by themselves and 1.
Right.
We're going to uncover their secrets and explore why they're way more than just building blocks of the number system.
Yeah. They're fascinating.
And to guide us, we have this amazing exploration of prime number patterns.
Oh, this is going to be fun.
Buckle up. It's about to get interesting.
You'd think with that super simple definition, prime numbers would be like straightforward.
Yeah.
Right? But that's what makes them so cool. They're incredibly complex with these patterns and mysteries that have puzzled mathematicians forever.
I'm already hooked.
Yeah.
So how do we even begin to unpack all of this?
Yeah.
What's the first sign that prime numbers are more than they seem?
Okay, well, imagine listing out all the numbers, starting with 1, 2, 3, and so on. And as you keep going, you'll notice something about how often those primes appear.
I'm going to guess they show up less often the further you go.
Bingo! Exactly. But here's the thing. It's not just random. There's a pattern to how they thin out, a sort of order to their appearance. And that's the first clue for mathematicians that there's something deeper happening.
So even though they appear less often, they're not just randomly scattered.
That's it. And this predictability, this pattern, it challenges the idea that prime numbers are just, well, random. It suggests a structure underneath it all.
Wow, a hidden structure. Okay, tell me more. What kind of patterns are we talking about?
All right, well, let's take twin primes, for example. These are prime pairs that are just two numbers apart, like 3 and 5, or 11 and 13. They pop up all over the prime number sequence.
It's like finding matching socks in the laundry. But I bet it's more than just a coincidence, right?
You bet. There's this famous idea, the twin prime conjecture, which says that there are an unlimited number of twin primes. Mathematicians have found tons of them, bigger and bigger, but proving they go on forever. That's the real challenge.
Okay, so twin primes are a fascinating pattern. What other clues are mathematicians looking at to understand how prime numbers are organized?
Well, let's look at something called arithmetic progressions. These are sequences of numbers with a constant difference between them, like 5, 8, 11, 14. The difference is always 3.
Oh, right, like multiplication tables from back in school.
Exactly. And the amazing thing is that prime numbers can be found within these progressions, not randomly, but in infinite numbers. It's crazy.
Wait, infinite primes in these progressions. How?
That's where the Green-Tau theorem comes in. It proved that in any arithmetic progression, as long as the difference isn't 0, you'll find an infinite number of primes.
Oh, that's huge. So it's not just individual primes, but how they fit into these bigger mathematical structures. That's incredible. But I'm getting the feeling these are just parts of a much larger puzzle, right?
Absolutely. We still have so much to learn about prime numbers, which leads us to one of the greatest mysteries, the Riemann hypothesis.
I've heard of that. One of the biggest unsolved problems in mathematics, right? Something about a pattern in how primes are spread out.
That's the one. It proposes a very specific and complex mathematical function that describes how prime numbers are distributed. Think of it like a blueprint for where they are. If we could prove it true, it would unlock so much understanding, not just about primes, but potentially even areas like physics.
Wait, so figuring out these seemingly simple prime numbers could help us understand the universe. Mind blown. But hold on, you mentioned something about fluctuations in how primes are distributed.
Right, it's not perfectly uniform. They vary in how dense or sparse they are. But the fascinating thing is, even with these small-scale fluctuations, there seems to be a trend toward regularity when you zoom out and look at larger scales, almost like a rhythm to the primes.
So it's not all randomness. There's an underlying order, even if we don't fully get it yet.
You got it. The more we explore these patterns, the more we realize how much more there is to uncover about these mysterious numbers.
Okay, I am officially hooked. But before we get too lost in the theoretical, you mentioned earlier that primes have real-world uses. I'm really curious about how these abstract ideas actually affect our daily lives.
Oh, get ready to be surprised. Because prime numbers are crucial for something you use all the time. Cryptography.
Cryptography, you mean like codes and secret messages? How do prime numbers fit into that?
Well, it turns out that the challenge of factoring large numbers into their prime parts is the basis of many secure encryption methods, like the RSA algorithm. It's like a lock that's nearly impossible to pick unless you know the exact prime number keys.
So prime numbers are protecting our digital world. That's incredible. Never would have guessed that these simple numbers were so powerful.
It really shows how much we depend on prime numbers, even without realizing it. They're essential for online banking, secure communications, and so much more.
Okay, you've piqued my curiosity. What else is out there in this prime number landscape waiting to be explored?
Well, there's a fascinating visual representation of prime numbers called the Ulam spiral that reveals some truly unexpected patterns. It's a visual treat.
A visual representation of prime numbers. Now you've got my attention. Sounds like the perfect place to start in part 2 of our prime number deep dive.
Okay, so let's unpack this Ulam spiral. It's a really cool way to visualize prime numbers.
Okay, I'm all ears. How do you even make a Ulam spiral?
All right, so picture a grid, right? But instead of just going in rows and columns, the numbers spiral outwards from the center.
Okay.
So you start with 1 right in the middle,
Okay.
then 2 goes to the right, 3 goes above it, 4 goes above 3, and you keep going like that, spiraling outward as you add more numbers to the grid.
Okay, I can see it forming in my mind.
Now here's the cool part. Once you've got your spiral, you highlight all the prime numbers. And what you'll see is not just a bunch of random highlighted numbers. Instead, you get these distinct diagonal lines, horizontal lines, even vertical lines, all grouping those primes together.
Whoa, so the primes, with their hidden order and all that, they make actual visual patterns in this spiral. That's amazing.
Yeah. And that's one of the things that makes the Ulam spiral so compelling.
Right.
It shows us that there's more to how prime numbers are spread out than we might first realize. These patterns in the Ulam spiral suggest deeper mathematical relationships that we're still figuring out.
Okay, I have to say, seeing those patterns in the spiral really shows that prime numbers aren't just random. There's a structure there waiting to be discovered.
Exactly. And that's what keeps mathematicians going. It's like we're piecing together a huge puzzle, and the Ulam spiral gives us this glimpse of how the pieces might fit.
Yeah, that's a great analogy.
So we've got twin primes, these arithmetic progressions, the mind-boggling Riemann hypothesis, and now this Ulam spiral.
Right. What other clues have mathematicians found in their quest to decode these prime number patterns?
Okay, let's talk about prime gaps. These are the spaces between consecutive prime numbers.
So, like, the prime gap between 7 and 11 would be 4, because you have 8, 9, 10, and 11 between them.
You got it. And prime gaps are really interesting because they vary so much. Sometimes primes are really close together, like twin primes.
Right.
And sometimes they're spread really far apart with big stretches where there aren't any primes at all.
It's like they're playing hopscotch, taking tiny steps or giant leaps across the number line.
Love that. And as mathematicians have studied prime gaps, they've found some cool patterns. For example, there's this thing called the prime number theorem, which lets us estimate how many primes there are up to a certain number.
So it's like a tool to predict, roughly, how dense or sparse prime numbers are as you go up the number line.
Exactly. It doesn't tell you the exact location of each prime.
Yeah.
But it gives us a general idea of how they're spread out. And even though we have this proven theorem, mathematicians are always working on refining those estimations and understanding the finer details of prime distribution.
It's like they're creating a more and more detailed map of this prime number landscape.
Yeah. Precisely. Every new discovery gives us another piece of the puzzle, bringing us closer to understanding the patterns that drive these amazing numbers.
You know, thinking back to our conversation of the Riemann hypothesis, it seems like everything's connected.
Mm-hmm.
The Ulam spiral, the prime gaps, the prime number theorem, they all point towards the same puzzle.
You're absolutely right. Each of these ideas offers a different viewpoint on how prime numbers behave and how they're distributed.
Yeah.
And if we could ever prove the Riemann hypothesis, it would be huge. It could revolutionize our understanding of these patterns and maybe even uncover connections we haven't even imagined yet.
This whole deep dive has been amazing. I'm so impressed by how these seemingly simple numbers can lead to such complex mathematical ideas and mysteries.
Yeah. It shows us that curiosity and digging deeper can lead to some amazing discoveries. Prime numbers might look simple on the surface, but they're packed with complexity and wonder.
So true. But, before we drift too far into theory, we touched on this earlier, prime numbers actually impact our lives every day.
Oh, absolutely.
I'd love to dive into that a little more.
Let's do it.
So how do these theoretical prime numbers actually affect us in practical ways?
You're right. Let's not forget about that. Remember our talk about cryptography?
Yes. That really surprised me. Like, I'm online banking and sending secure messages all the time, but I never thought about prime numbers being the reason I can do that safely.
It's pretty incredible, right? As we rely more and more on digital everything,
Yeah.
Understanding and using the power of prime numbers becomes even more important.
Okay, so can you remind me how exactly prime numbers keep our digital lives safe?
It all goes back to how difficult it is to factor large numbers into their prime components. Many encryption algorithms, especially the RSA algorithm that's used everywhere, they use this difficulty to create secure systems.
Right, it's like that lock we were talking about.
Exactly, a lock that can only be opened if you know the prime number combination.
Exactly.
So think of it like this. To encrypt a message, you use a public key that comes from a really big number. That number is actually made up of two secret prime factors. Okay.
Anyone can use the public key to encrypt a message, but to decrypt it, you absolutely need to know those two secret prime factors.
So it's like a mailbox with a combination lock. Anyone can put mail in, but only the person with the right combo, those secret prime factors, can actually open it and get the mail.
Perfect analogy. And because it's so computationally hard to factor that big public key number back into its original prime components, the message stays safe and sound.
So the bigger those prime numbers, the tougher the encryption.
Absolutely. And as computers get more and more powerful, we need to use even bigger prime numbers to keep that level of security. It's a constant race, like a chess match, between the people who make codes and the people who break them, with prime numbers right at the center.
It's amazing, right? Prime numbers might seem abstract, but they're literally woven into how our digital world works.
They really are.
Yeah.
And it goes way beyond just cryptography. Remember how we talked about them being used to make algorithms run better?
Yeah.
Well, they're even being explored in cutting-edge areas like quantum computing.
Quantum computing. Okay, I've heard that term, but I'm not sure I fully understand it. What do prime numbers have to do with that?
So quantum computers are totally different from the computers we use every day. They use the laws of quantum mechanics to do calculations.
Whoa.
And guess what? Factoring large numbers into primes, the problem that makes prime numbers so useful for cryptography is something quantum computers might be really good at.
So does that mean quantum computers could break the encryption we use now?
That's definitely a concern, and a lot of smart people are working on it. There's a big push to come up with new encryption methods that can hold up against quantum computers, and you can bet that prime numbers will still be super important in this new era of digital security.
Wow, this whole conversation is making me realize how much potential there is in these prime numbers.
Right.
It's not just about the math, it's about all these different fields and how they connect. But, what really blew my mind earlier was that link you mentioned between prime numbers and, like, the laws of physics. That's what I'm really curious about.
Yeah, that's definitely one of the more mind-bending areas of research. It asks some really big questions about the nature of reality itself.
Okay, you have to tell me more. How could prime numbers, which seem so abstract and mathematical, be linked to the actual physical world?
It's like trying to find the hidden tune in what sounds like a random jumble of musical notes. Researchers are looking for those hidden patterns, those connections between the way prime numbers behave and the way physical systems work.
So they're searching for some kind of mathematical harmony that links these two seemingly separate things together.
Exactly. And even though this research is still pretty new, there have been some really intriguing hints.
Like what?
Well, some researchers have found possible connections between the distribution of prime numbers and things like the energy levels of atoms,
Wow.
or how subatomic particles act.
Wait, so you mean the same math that governs primes might also affect the tiniest bits of matter in the universe?
That's one of the possibilities. Imagine if we discovered that the distribution of prime numbers, which seems so random,
Yeah.
actually reflects a deeper order.
Right.
A mathematical blueprint that underlies how the universe is structured. That would be a game changer.
It would change everything about how we understand both math and physics. It's crazy to think those prime numbers could be a key to understanding how reality works.
That's what's so amazing about science.
Yeah.
We're constantly questioning, discovering, and updating how we see the world. And prime numbers, with all their mysteries and unexpected connections, are going to keep scientists busy for a long time to come.
This deep dive has been an incredible journey. We started with this basic definition of prime numbers, and now we're exploring the cutting edge of math, computer science, and even physics. It's a great example of how even the most fundamental concepts can lead to amazing breakthroughs.
It all comes back to that human drive to understand our world,
Right.
to look for patterns and to solve the mysteries around us. Prime numbers might look simple, but they've turned out to be a gateway to some of the deepest, most challenging questions we can ask.
That's a great way to put it. And to all our listeners, keep exploring, keep those questions coming, and never underestimate the power of curiosity. You never know where it might take you. All right, welcome back to our prime number journey. I'm still thinking about that connection between prime numbers and the laws of physics. It sounds almost unbelievable.
Yeah, it's definitely a bit out there. But that's what makes exploring these ideas so exciting. We're kind of pushing the boundaries of what we usually think about with prime numbers. It's like stepping into this uncharted territory where math and the mysteries of the universe could be intertwined.
Okay, color me intrigued. But before we go too far down that rabbit hole, let's revisit cryptography for a minute.
Mhm.
In part 2, we talked about how the difficulty of factoring big numbers into their prime parts is what makes secure encryption possible,
Right.
and how this concept is what keeps our digital world safe and sound.
Exactly. It's the invisible force field protecting everything from our online banking to those top secret emails we send.
It's wild to think that something as abstract as prime numbers can have such a real concrete impact on our everyday lives.
It really is. It shows how powerful human ingenuity is and how interconnected knowledge can be. I mean, we figured out how to use these special properties of prime numbers to create systems that ensure privacy, security, and trust online.
Okay, so I get that prime numbers are the guardians of our digital lives. But how do they actually do it? Can we break it down a bit more?
Absolutely. So, say you want to send a secret message to a friend. With an encryption algorithm like RSA, you first create a public key based on a massive number made up of 2 secret prime factors. These factors act like unique keys to a lock.
Ah, okay.
Anyone can use that public key to lock up a message to encrypt it, but only someone with the secret prime factors can unlock it or decrypt it to read the message.
So it's like that mailbox analogy again.
Yes.
Anyone can drop a letter in, but only the person with the right combo knowing those secret prime numbers can actually open it.
Exactly. And because factoring that huge public key number back into its original prime components is ridiculously hard, even for powerful computers.
Yeah.
The message stays secure.
Okay, so the larger the prime numbers used, the more secure the encryption, right?
Exactly. It's like trying to find a needle in a haystack the size of, like, a galaxy. And as computers become even more powerful, we need to use even bigger prime numbers to stay ahead of the game. It's like a constant arms race, with prime numbers as the secret weapons.
This is fascinating. I had no idea prime numbers played such a vital role in our digital world.
They're the unsung heroes of cybersecurity for sure. But, it doesn't stop there. Remember how we talked about them being used to fine-tune algorithms? Well, get this. They're even being explored in the mind-blowing world of quantum computing.
Quantum computing. I know that's a hot topic these days.
Right.
But I don't really get what it's all about. How do prime numbers fit into this futuristic kind of computing?
Quantum computers operate on a whole other level. They use quantum mechanics to carry out calculations in ways that are impossible for our everyday computers.
Right.
And prime factorization, that super hard problem that makes primes so valuable for cryptography, well, quantum computers might be able to crack it wide open.
Oh, wow. So does that mean all our current encryption methods, the ones that rely on prime numbers, could become obsolete when quantum computers become mainstream?
That's the million-dollar question, and researchers are scrambling to figure it out. The quest is on to create new encryption techniques that can withstand the power of quantum computers, and I guarantee that prime numbers will continue to be a key part of that.
It's crazy to think about
Yeah.
how this one concept can lead to so many breakthroughs.
Absolutely.
But let's circle back to that mind-blowing connection you mentioned earlier between prime numbers and the laws of physics. That one really piqued my curiosity.
Yeah, that's a fascinating and maybe even a little bit radical area of research. It raises some really profound questions about how the universe works. Some physicists and mathematicians believe there might be a hidden link between the seemingly random scattering of prime numbers and the fundamental laws that govern everything around us.
Okay, I'm hooked. How could something as abstract as prime numbers be connected to the actual physical world?
It's like searching for a hidden melody in a sequence of random notes. Researchers are looking for patterns, connections, and relationships between how prime numbers behave and how physical systems operate. It's almost like trying to find a hidden code that connects the two.
So they're looking for this underlying mathematical harmony that connects two seemingly unrelated things. That's pretty wild.
Exactly. It's definitely a long shot.
Yeah.
But there have been some pretty cool hints along the way.
Like what?
Well, for instance, some research has shown potential links between how prime numbers are distributed and the energy levels of atoms.
Whoa, seriously.
Yep. And also with the behavior of those tiny particles that make up everything.
Okay, hold on. Are you suggesting that the same mathematical rules that govern prime numbers could actually influence how the tiniest building blocks of matter behave.
That's one of the big questions that's being explored right now.
Wow.
Imagine if we find out that the seemingly random distribution of primes actually reflects some deeper hidden order, like a mathematical blueprint for the entire universe. That would be a revolution in how we understand the world.
It would change everything. It's mind-blowing to think that these seemingly simple prime numbers could hold the key to understanding the universe itself.
It's pretty amazing, isn't it? And that's what I love about scientific exploration.
Yeah.
It's all about constantly questioning, discovering, and updating our understanding of the world around us. Prime numbers, with all their mysteries and weird connections, will continue to fascinate and inspire us for a long time to come.
This deep dive has been a wild ride. We started with this simple definition, and we ended up exploring the frontiers of math, computer science, and physics. Who knew that such a basic concept could lead to such mind-blowing discoveries?
It really shows us that even the most fundamental ideas can lead us to extraordinary places. And it all boils down to that innate human curiosity, that drive to understand, to seek patterns, to uncover the mysteries that surround us. Prime numbers, for all their seeming simplicity, have become this gateway to some of the most profound and challenging questions we can possibly ask.
That was amazing. And to all our listeners, we encourage you to keep exploring, keep asking questions, and never, ever underestimate the power of curiosity. You never know what amazing discoveries you might make. Until next time.